Alright, so here we're going to work to find the surface area of some triangular prisms. Alright, so question 1. Charlie needs to determine how much fabric he needs to purchase in order to create his own pup tent. Okay, so fabric, when you buy it or order it, is going to come in some sort of square measurement. It's going to say some number of square centimeters, or more likely, some number of square feet, or maybe square meters. Because a fabric is dispensed as an area, not as a distance. And so we need to make sure we're looking to find out how many square units that we're going to be concerned with if we want to build a pup tent of these dimensions. We need to know what we need to order. All right, so question 1, A, says we're going to break this up by drawing and labeling a net diagram. That's going to show how the tent looks if we fold it out. And a net diagram is just taking a three-dimensional shape like this and turning it into a folded out two-dimensional shape if it all folds out nicely. All right. So this is not an easy task. It takes a bit of practice. Now, I can imagine taking some scissors and say, cutting along each of the edges here, cutting this along and cutting along here, and then maybe cutting down this edge and down this edge down here. And there would be an invisible edge back here that we can't see because the tent's in the way, but we would imagine it's still there. Okay, and if we fold all these sheets out, what's that going to look like? Okay, well, luckily we have seen some of these shapes already in class. We know that it looks something like this. This guy will fold out this triangle and form a triangle on the ground. And this large rectangle will fold out and make a large rectangle on the ground. And lastly, this triangle in the back will also fold back and form a triangle on the ground. And this sort of shape, we know from experience, looks something like this. In fact, they all tend to look the same. All triangular prisms if you fold them out. Okay. So the challenge then is going to say, okay, well, if that's the shape that these look like when they're all folded out, well, I guess I have to label which dimension from this diagram, 1.3, it's 0.9 meters tall, it's 1.1 meters along the edge, 2 meters long. Okay, so where do these all fit? So I'm going to look at this diagram and imagine, okay, I can see that the base of the tent where people would sleep and lie on, that part of the fabric, well, that looks like it's the middle. And so I'm going to record the dimensions of this rectangle as the dimensions of this middle rectangle. All right, and it looks like this rectangle is 1.3 meters wide, 1.3 meters, and it looks like it's 2 meters long. 2 meters long. Now I can also tell that if this is 2 meters, then this must be 2 meters. And this must be 2 meters. And again, this must be 2 meters. And also this one must be 1.3 meters. All right. Let's move on to this rectangle here. I guess that would correspond to this rectangle here. Okay, and if it folds out, obviously this would be 2 meters long along here, but how long is this side? Well, this side probably would have corresponded to be laid along this edge of the tent. And the diagram doesn't actually give a length of that side. However, it does give a length of this side. And we're meant to infer that these two would be the same length because this tent is probably symmetrical. Okay, so if this edge is 1.1 meters, we can imagine this edge would also be 1.1 meters, and when we fold it out, that means this edge would be 1.1 meters, which in our net diagram means this one would be 1.1 meters, which means, of course, the top one would be 1.1 meters. And I realize now these rectangles are not drawn perfectly to scale. I probably drew this one a little bit too big, but in fact the measurement is a little bit smaller, a little bit less long than this one. And so I could have drawn this diagram more perfectly, but I think it's going to serve us just fine. And we're going to find, if we look at this rectangle, again, it's going to correspond to this other section of unfolded bit of fabric. Then we'll have the same dimensions. This 1.1 meters will be lying along here, 1.1 meters, and it'll be 2 meters long. Okay, so we'll label this guy to be 1.1 meters, and that one to be 1.1 meters. And that leaves us only with the triangle. Now, if we look at this diagram, we can see that the triangles have a height of 0.9 meters. And I know from experience that the height of a triangle is a very important quantity. So I'm going to make sure to write down that the height of this triangle is 0.9 meters. And that's the same with this height down here, 0.9 meters. Now, you may have found this wasn't enough room for you to have drawn that net with all its detail, and you are perfectly free to do so on a piece of grid paper or some other larger piece of paper if you like. And, oh, I guess we're missing a few sides. I didn't label how long this side of the triangle is, or how long this side of the triangle is. Well, maybe if I look at my diagram, I can see that that would correspond to this edge here of 1.1 meters, and this would be 1.1 meters as well, and that'd be the same down here, 1.1 meters, 1.1 meters, and now I'm done. Part B says find the area of each section of the tent. Okay, well, I can see there are 5 different sections of the tent, and I can see that there are 1, 2, 3 rectangles, and there are 2 triangles. Okay. And I also happen to know that the area of any rectangle is just its length times its width. And I know the area of any triangle is 1/2 times the length of the base of the triangle times the height of that triangle. Okay. So I guess we'll go one at a time. I think maybe I will letter these just to make it easier for me. So I'm going to call this part face A. I'm going to call this face B. Call that face C. This will be face D. That'll be face E. Okay. So that'll just help me keep track and help me recognize if I've found the area of all my bases or of just some of them. All right. I said bases, I meant faces. All right, so let's find the area for section A. Okay, that is a triangle. So the area of a triangle. All right, and that's equal to 1/2 times the length of the base times the height. Okay, so that's 1/2 times the length of the base of that triangle is 1.3 meters. And the height of the triangle is 0.9 meters. Okay, and that is some number. I'll just put that in. 1/2 times 1.3 times 0.9. And that gives me an area of 0.585. And we're measuring area, so that must be in meters squared, square meters, which is about 1/2 of a square meter. Okay, a little bit bigger. Great. Moving on, we'll talk about area B as area of a rectangle. Okay, and area of a rectangle is length times width. So if I look at this rectangle, I see that's going to be 11 meters in length and 2 meters in width. So it'll be oh, did I say 11? I meant 1.1 meters by 2 meters. And you know what? I don't even need a calculator for that. I can see that's going to be 2.2 square meters. All right, great. Moving on, find section C. And that is also a rectangle, so it's also going to be length times width, but the dimensions of this inner rectangle are a little bit bigger, despite how the diagram makes it look. It looks like it's 2 meters and 1.3 meters. So 1.3 meters times 2 meters. Okay, and I know when I multiply that by 2, I get 2.6. That's 2.6 square meters. Grand. All right, now moving on, we'll go on to section D. And this rectangle, 1.1 by 2, is actually going to have the same area, I can see, as 1.1 by 2, this section B. So I don't even need to do the calculation. I can just say that it's going to be 2.2 meters squared. And if I write down section E, this last triangle down here, I also recognize that the triangles on the bottom and the top have the exact same dimensions. So the area of that triangle, well, that's going to be 0.585 meters squared, the same area as the area of this triangle. Okay, I'm going to put big squares around these, so it's nice and easy for me to find my measurements later, and I don't get confused when I look at a whole page full of writing. And the last part of this question, question C, well, Charlie's going to need to know the total surface area of this entire tent. Okay, so we're going to add all of these surfaces together to find out how much fabric Charlie's going to need to order to make this tent. So we're going to add the total surface area. Oops, it's going to be equal to 0.585 meters squared plus 2.2 meters squared plus 2.6 meters squared plus 2.2 meters squared and plus 0.585 meters squared. Now you may have noticed there's a couple of duplicates here, so rather than add them twice, I could have taken one and just multiplied it by 2. I could have done that with the 0.585 and the 2.2. But in order for clarity, I'm just going to add them one at a time. Okay. So that's going to give me 0.585 plus 2.2 plus 2.6 plus 2.2 plus 0.585. Okay, and it gives a total surface area of 8.17 square meters. And since it's a word problem, I'm going to add that we're talking about fabric. It's nice to remind ourselves what we were looking for in the first place, and it was a type of fabric, a certain amount. All right, and I like to put a big box around my final answer so I can easily find it later if I need it. Okay, let's flip over the page. So we've got one other question, and it has an identical type of shape. All right, so this one is a little bit different. Amel bought a Toblerone and he wants to gift wrap it for a friend. And so he's going to need to find out how much wrapping paper he'll need. And again, wrapping paper is a quantity that we're going to be expressing as an area, not as a distance. All right, so if we look, we see, okay, question A, question B, question C, they're pretty much the same as they were in the last question. Okay, so I'm going to repeat these steps. I'm going to try to make them go a little bit more quickly this time. So again, we're going to need to unfold this diagram. We're going to imagine what it looks like all folded out. So that means this whole flap is going to fold out like this, something like that. This one's going to fold down. It'll come out like that. This other triangle in the back, which we can't see, but we can infer is there. And then this guy's going to fold out as well. Okay. And again, I like to start with the middle base object, the one that kind of stays where it is. So I'm going to draw that first. And the one thing I'm going to do differently than I did last time is I'm going to add the dimensions as I go rather than all at the end. I'll show you a different way of going about it. Okay, so this base part of the Toblerone, well, it looks like it has some dimensions. It's 32.4 centimeters long. Okay, that goes all the way across. And it also looks like it is 6.4 centimeters wide. Okay. I could have labeled that a little bit more clearly. I'll make my M a little bit bigger. Okay, well, that's going to be a little imperfect. All right. And I can see it's going to have some longer flap out here. And this time I'm going to try and draw it a little bit closer to scale. Okay, perfect rectangle. All right, and as we can see, well, this rectangle is going to be 32.4 centimeters long as well, but the width here, well, that's going to correspond to the width along here, which is not labeled in the diagram. However, if I look out to the very back of the diagram, I notice that this diagonal is offered at 7 centimeters. Oh, so I didn't make it to scale after all. Okay, great. Well, all right, that's 7 centimeters. And that'll be 7 centimeters as well. And this will be 32.4 centimeters in case I get confused. Okay, great. And then I'm going to label this one all the way across. And it's going to have the same dimensions, 7 centimeters. This is 32.4 centimeters and 7 centimeters. Great. And this triangle out here, well, it looks like it has a height of 6.2 centimeters. 6.2 centimeters. And this one has a height of 6.2 centimeters as well. All right, and you might notice I didn't label these diagonals along the triangle. And you might have noticed in the last calculation we didn't actually end up using them, so I'm not going to calculate them, or rather include them. All right, now we're going to find the area of each of the sections. I thought actually labeling it worked kind of nicely last time, so I'm going to do that again. But I think I'm going to pair them up this time. So I know this shape, A, and this shape B have the same area. So I'm going to label them and find their areas together. This triangle C and this triangle D again have the same area. And this middle guy has his own area. Okay, cool. So we find the area of each of the Toblerone, or each section of the Toblerone surface. All right, so we'll start with A. All right, that's a rectangle, which means length times width. So the area of that rectangle is going to be 7 centimeters times 32.4 centimeters. All right, and if I multiply those together, 7 times 32.4, 226.8. 226.8. 226.8 watts. 226.8 centimeters squared, a square centimeter. And just as a reminder, I know I'm hammering this point home, but it's very important. 1 centimeter looks like this. It is a distance, but 1 square centimeter is a square with 1 centimeter along each edge. And this is what a centimeter squared looks like. So if we're picturing 226.8 of them centimeters squared, we're looking at 226.8 of these little squares covering the side of a Toblerone, which to me makes it seem like a pretty big Toblerone. All right. Now, I paired these together. We're talking about area B. We know it's the same dimensions, and so I'm just going to write down that that's 226.8 centimeters squared as well. And we'll move on to section C. Section C says, okay, that's 6.4 centimeters. Oh, right, that's a triangle. That means the area of this triangle, well, that's going to be 1/2 times the length of the base of that triangle, which is 6.4 centimeters, times the height of the triangle, 6.2 centimeters. Okay, I'll grab a calculator and I'll say, okay, well, how big is 1/2 times 6.4 times 6.2? 19.84. And again, we're talking in centimeters squared. And I know there's another triangle with identical dimensions to this one. So I could, if I wanted to, just multiply that by 2. I'm going to, again, just find these separately just to added clarity here. And that'll be 19.84 centimeters squared as well. Lastly, section E, I'll try and pick this up a little bit. Well, that looks like a rectangle, area of a rectangle. And it looks like the length is 32.4 centimeters. And the width is 6.4 centimeters. Okay, 32.4 times 6.4. All right, and that is 207.36 centimeters squared. All right. And lastly, to find the total surface area, I'm just going to add all these together. So 226.8 centimeters squared plus, another 226.8 centimeters squared. Rather than write these out twice, I'm actually going to just write 2 times 19.84 centimeters squared. You can do that for these other faces as well if you want to make your life a little bit easier. And I think since we've gone through one the long way, I'll quicken this up a little bit. 207.36 centimeters squared, and that is all the faces. Okay. So lastly, find my answer by saying, okay, well, I've still got this one saved in my calculator, so maybe I'll go backwards. I'll add to that 2 plus 2 times 19.84 plus, and I'm just going to do 2 times 226.8 because they are the same. And that gives me an area, total surface area, 700.64 centimeters squared.